So we are going to actually be solving our friend a quadratic equation. So let's identify first what a quadratic equation is. The most simple form of a quadratic equation is going to be kind of like standard form, where you have ax squared plus bx plus c is going to give you some number. And in this case, generally we say equals to 0. Okay, so it's standard form. Everything is on one side, and we're solving for it. We're trying to get the x by itself. But again, doing that is overly complicated. So we're going to use a very, 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 very simple multiplication trick to get the answer. And that's called the zero product property. So the zero product property says this: let a and b be real numbers, in other words, not imaginary. And if a times b is 0, what's got to be true about one of those numbers? A times b is 0. Then one of them has to be 0. We don't know which one, or technically both of them could be 0. But one of them has to be 0, no questions asked. Okay? So very, very basically here, if 9x equals 0, what's x equal? It equals 0. Yay, I solved it. Why? Because one of them has to be 0, and in this case, x. Same thing over here. Oh, 15a is 0, so a is 0. So how do I use the zero product property here? I have two expressions, an x and an x plus 2. And together they equal 0. So what's true about this first one or this second one? One of them has to be 0. So either the x is equal to 0 or the x plus 2 equals to 0. So notice what we've done. We started with this expression up here, which had multiple x's. And when I multiply this out, distributive property, I get x squared. That's a quadratic. But because of the nature of 0, I can split it up into linear equations. And now when you solve this, x is 0 remains the same, and x equals -2. So what are my two options? X is 0 or x is -2. It's one or the other. Technically, it could be both, depending on the context. So we have two options here. So when practicing the zero product property, we already have it in factored form. I know it's factored because this is multiplication right here. So all this says is, number one, we split each one of these up. Just take the parentheses themselves, or each factor, we would say, and set them equal to 0. So solving the left one, I get -2. And solving the right one, I get +3. So this is the answers, or the solutions. And of course, always check. Either you're checking mentally, or you're checking all the way, or you just substitute in. So let me go ahead and substitute in the two. One at a time, folks. Only do one at a time. So I'm going to say -2 plus 2 times -2 minus 3 equals 0. Again, what did I do? I put the -2 right here and right here. Oh, but Swenson, why didn't you put them both in? Because I'm just checking to see if this one works. Then I'm going to go over and check if this one works. Now, the next step here is this gives me 0, and this one gives me -5, and together, does that equal 0? And the answer is yes, because 0 times anything is 0. And now if I check the other one, I'm going to put a 3 in, so 3 plus 2, and a 3 minus 3 equals 0, and technically that's a question mark. So 5 times 0 equals 0, and we see that there's a check there. So when I substitute in a -2, 0 equals 0, that's true. When I plug in a 3, 0 equals 0, and that's also true. So here are my two solutions, -2 and +3. So let's look at number 13. That's slightly more complicated looking, In other words, when we do the split, it will have more steps to solve. So I recognize that I have factors because of this multiplication. So because of that, I can split the equation using the zero product property. So 3x minus 7 is one of my equations, and 2x plus 1 is the other equation. Now I'm going to solve individually. I add 7 to both sides to get 3x equals 7, and divide by 3 to get 7/3. Finishing up the other one, I get 2x equals negative 1, and x equals negative 1/2. And my first instinct here says, oh crap, I have fractions. I must have done something wrong. And the answer is, most of life is fractions and decimals, so don't assume that. So I'm going to go ahead and do a check real quick. When I plug in the 7/3 in the very first expression, what's going to happen is everything's going to drop out really, really nicely. I don't even have to deal with the second fraction so much. So as we do this, again, it looks complicated, but the very first one here, 3 divided by 3 gives you 1, so you get a 7. 7 minus 7 is 0, so it actually does not matter what the next thing is. But just for clarity's sake, the next thing is 14. This is 14 over 3, and then add 3 over 3 to that, so it's 17 over 3, but equal to 0, and of course 0 equals 0, so I'm done. Again, no matter how complicated it looks, in the end, I'm multiplying by 0, so it kills everything on that side. So again, just because you have a fraction for a solution doesn't mean you're wrong. In fact, the check here is fairly quick. All right, so what we're going to do is take the two concepts we have, factoring, and the idea of the zero product property, and if we can start from an equation, a quadratic equation, we're going to factor it, then split it, and then solve individually. So that's where we're going to be working. Now again, use Snowflake. When I say use Snowflake, this is just a suggestion. Factor it however you want. Okay, if you factor it by a special product, if you factor it by grouping or some other method that you know, that's fine. But I recognize over here that I already pulled out my GCF. The only GCF is a 1, so I did a quick check for GCF. And now I'm going to start filling it in. A times C is negative 6. B is 1. It's hidden in the front just to show you. B is 1 there. And then I'm going to put 1x on the flanks there. Now continuing on, and quickly, the only two numbers that multiply to negative 6 but add to a positive 1, 3 and negative 2. So now, how does that help me? Well, I'm going to factor the expression x plus 3, x minus 2, and bring down the equals 0. All I did was substitute and factor this side, equals 0. So there's my first big step. Factor the quadratic expression. Now the zero product property says if factors multiply to 0, then one of them at least is 0. So I split the two equations, use the zero product property to split the equations. Now to finish this up, x is going to give you a negative 3 here. X is going to give me a positive 2 here. Remember, box or circle. And then I just do a quick check. Notice where my check belongs. My check does not belong here like we did on the front of this page. My check belongs up at the original problem. So I'm going to take a negative 3 and square it according to this right here. Square it. Then I'm going to add a negative 3, subtract 6, and does it equal 0? So I substituted back into the original problem. And now negative squared is positive, so this gives me a 9. Minus 3 minus 6 equals 0. And 9 minus 3 minus 6 is 0. So I did a check for the -3, and that one definitely works. Notice I didn't check both numbers at the same time. I didn't put the -2 in, or the +2. I'm going to walk through the 2 real quick. When you put a 2 in, 2 squared here is 4, plus 2 is 6, minus 6 gives you 0. So a quick mental check on the 2 shows me that it does work. Another thing I would like to point out is the variation of instructions. So just to give you a heads up, number 1 says, find the roots of the equation. Number 2 says, find the solutions of the equation. Number 3 says, find the x-intercepts of the function related to this. And lastly, find the zeros of the equation. So all of these, roots, solutions, x-intercepts of the function, zeros, they're just funny ways of saying the same thing. The same thing being, solve it. So now let's take a gander at a slightly more complicated situation. In this case, we have a is not equal to 1. So when I set up my snowflake, like so, I put a -42 because I said -21 times 2. And then this -1 goes in the bottom. The b goes in the bottom. I'm going to put a 2x on the flanks there. And in future, I might want to give myself a little bit more room on the right side, just in case I have to simplify that side. So I think of the 2 factors of -42 that add to -1. So it seems like a 6 and a 7 somehow fits, but one of them has to be negative, so which one is it? The bigger, since I add to a negative, the bigger looking number should be negative. So there we go, -7. And this side reduces to x over 3. So when I bring the factors across, I get x plus 3 times 2x minus 7. All that equals 0. X plus 3 and the 2x minus 7. Now I can split, so x plus 3 equals 0, and 2x minus 7 equals 0. X is -3. And on this other one, I get x equals 7/2 or 3.5, however you would like to say that. Do a quick check with the -3. When I plug a -3 right here, I get 9, and doubled is 18, and subtract a -3 to get a 21, so all of this is 21, minus 21 does equal 0. So if we look at this problem here, we're going to suppose you're building a storage box, volume 4,368 cubic inches. The length of the box will be 24 inches, so we already have a solidified number. The height of the box will be 1 inch more than its width. 1 inch more than its width. Find the height and the width of the box. So, since we already have a 24, we know that we could effectively pull the 24 out of this. Pull the 24 out of this. But let's take a moment to draw a diagram of that. So, 24 inches will be the length of the box. So let's just say 24 right there. We don't know what kind of box. I mean, rectangular is implied. So what we do know is that the height of the box, so if this is the width, the height of the box will be 1 more than the width. That's what it says. The height of the box will be 1 inch more than the width. So ultimately, what we're trying to figure out is what's the side dimensions? Because we already know one of the dimensions right here. So we're just trying to figure out the side dimensions. So formulas that we're dealing with. Volume, back in your geometry days, volume is length times width times height, or you could say base, capital B times height, capital B, the area of the base. But we already know one of these numbers, right? So I'm going to go ahead and substitute some stuff in to see what we have. So I'm going to substitute the 4, 3, 6, 8 right there. And then I have one of them is 24. Then I have a W and a W plus 1. So I just substituted in my variables and values. So let's show some work. I'm going to go ahead and divide by 24 on both sides, because ultimately my goal is to get W by itself. So 182 is equal to W times W plus 1. And continue the work over there, and there's a 1 there. All right. Now, we're not in standard form. Yes, I'm in factored form. It has factored, except it's not equal to 0. So it's not like I can set the W equal to 182 or the W plus 1 to be at 182, because this isn't the property of 182. It's the property of 0. So that splitting thing only works when this is 0. So what do? Do I just subtract this from both sides? Well, yes, eventually. But I'm going to distribute first. So in doing that, I get this, 182 is equal to W squared plus W. So I distribute that W across. And now I'm going to W squared plus W minus 182 is equal to 0. Now I can factor, and again, it doesn't matter which side that the 0 is on. So I'm going to factor this. I'm going to put a negative 182 in the numerator, or in the top there, a positive 1 on the bottom, and a 1W on the flanks. In 182. Offhand, I don't know 182 very much. I know it's divisible by 1. I know I end up with a positive number, so that looks like the smaller looking number needs to be a negative. That doesn't work, so let me try 2, negative 2, and that'll give me 91. So I'm just going to keep plugging some stuff into my calculator. I divide by negative 13. Where did I get that 13 again from? I see that it's a factor here, which means it's also a factor there. When you do that, you get 14 right here. So there we go. Here's a negative 13 and a positive 14. So now I can factor things. W minus 13, W plus 14, all equal to 0. So W minus 13 is equal to 0. W plus 14 is equal to 0. And to answer the question that came up earlier, will both of them work? Go ahead and discuss real quick with your neighbor. We're claiming that my width is 13 or negative 14. Which of these does not make sense? Discuss. All right, so the 14 is negative. Why? Because distance cannot be negative in the context of height and width. Distance cannot be negative. So we haven't answered the question, so let's make sure we go back and answer the question. We know that the length is 24 because they told us so. We know the width is 13 because it can't be negative 14. And lastly, the height of the box is 1 inch more than its width. So the height has to be 14. And how do we check this? 24 times 13 times 14. All we have to do is plug that in to see if we get the 4368. After we check it, it does indeed work.